Hello there, welcome to this Shieldia guide where I discuss how to install and configure the Tartarus Lab from the blue team perspective. If you tuned in for the red team, this is going to be very similar content, however specifically focused on the blue team perspective. So you'll find it on the blog shieldia.co, and then you'll see the blue team prerequisites guide. Here it'll break down and run you through exactly what you'll need. It's got some conventions, it's got some preamble and stuff. We don't need to worry about that at the moment. However, the specific software that you're going to need on your host system, I use VMware host guest language. The specific software that you'll need on your host is going to be Vagrant, which is how we manage these virtual machines. Go to their website and follow the installation guide for your specific host operating system. So whether that's Windows or Linux or Mac OS, I'm not going to judge. Then you're going to want VirtualBox. This is how the VMs get created. We went with VirtualBox because it's the easiest. It's what I know. There's really great documentation on how to actually interact with these guests from Vagrant with VirtualBox. So we went with that. And then VMware has it's had a bad taste in my mouth from using it and then having to reapply for licenses and then mess with registry keys. So instead, VirtualBox, I would however highly suggest you use the most up-to-date version because it fixes a VM escape. So definitely use the most up-to-date version and then follow the guide for your specific host operating system. Then you're going to want Git good. You're going to want to download it, install it, whether you're on Windows or Linux. It should work identically. It's a really powerful piece of kit. I highly also recommend reading the book. It's a great read. It's a bit long, but well worth it. Then you're going to want to make sure that you meet the minimum system requirements to run all of these virtual machines, because what we are essentially doing is installing an entire enterprise network on your host. So you're going to need at least 19 gigs of system memory or random access memory. I would through using this, 32 gigs is ideal. That's really where you want to be, because if you've got some browser tabs open, especially if it's Chromium based, you're going to use all of the RAM in existence. And then if Elasticsearch, specifically the Lucene JVM, if that runs out of memory, it's a bad time. It'll just crash it. And then you basically just have to restart that guest. It's not the end of the world, but it's not an ideal situation that you want to be in. 32 gigs of RAM or 64 gigs of RAM is ideal. So you can view that within Windows through Control-Shift-Escape. We'll bring up the task manager and then just tab over to your system information. So, or in Linux, we'll just do a /h and then that'll give us the total system memory. Same for the processors. So you're going to want at least, as it mentions here, 11 vcores. So most modern processors have what's known as hyperthreading. So you'd have one physical core, but that's actually two logical cores that, as the OS would see it. So you're going to want at least 12 or 11 vcores. 12 would be the optimum because that's 6 physical cores. So a hexacore, i7 or i9. I'm not sure if they do any i5 hexacores. And then AMD, whatever it is, I don't keep track. Then there is an option to deploy it as a blue min. This will set all of the system requirements to their absolute minimum on all of the guests. However, there may be some instability on the Elasticsearch host or guest, because the JVM needs at least 8 gigs of RAM and you're hosting Kibana on it as well. So there may be some instability. If that happens, you can tweak the Vagrant file to increase the RAM for that specific guest if that happens to you. So then that only requires 13 gigs of system memory and 6 vCPU cores, or about 3 physical cores. So with a quad-core modern processor, you'll be fine with that. Then you're going to want to follow the installation. It is located on GitHub. You're going to git clone the repository to your local system. So you can copy that out. And then in a terminal, Control-Shift-V to paste it. If you're in Linux, if you're in Windows, it's just right-click for whatever's in your clipboard will be pasted into the PowerShell window. So I'm just going to Control-C so we don't have to worry about that because I've already cloned it locally. Then you're going to want to cd into that directory that you've just created. It's bringing up the machines or the guests. So we're going to say export and then which Vagrant file we want, which is the default Vagrant file, which is creatively called Vagrant file. And then we're going to bring up. So Vagrant is the command, up is the subcommand, and then OpenSense is the specific box that we want to bring up that's defined in the Vagrant file. Once that's all done, the OpenSense FreeBSD firewall shuts down as its last step during the installation process. So then we're going to run another command once that's all completed and installed, which will be you specify a variable called hosts and then which guest we want all of the packages to be installed for. This defines a lot of variables in the back end so that Elastic and Kibana can be configured in the right way for that specific guest. So this damn vulnerable web app guest is different than the normal Linux or Windows guest. They're all required different packages to be installed. So we define that variable and then we again go Vagrant up, OpenSense so that some more configuration items can happen, and then Elastic, which is the SIEM, damn vulnerable web application, which is the target for today's exercise, and then Kali, which is how we will interact with that. So I've already run these, but you can just go copy and then paste that into your terminal. If you're on Linux, if you're on Windows, it's very similar, but they just call the environment variables a bit differently. But then it should be very similar for you. Now, once that's all installed, I'm just going to run through what you'll see in the installation script. So this is a very trimmed down version. There are some important variables that are set that you're going to need to note down specifically. So this is just the first time the firewall gets brought up, FreeBSD installs all of the required packages to run OpenSense. Then it shuts down the firewall. Then you're going to bring it up again. So then we can set through the firewall.php, we set the firewall rules via the API. We're not setting them via the XML config file. Instead, we just set them via the API because it's the easiest way that I've found. And then we also set a logging destination, which is the firewall, so that all syslogs from the it's the SIEM. For all syslogs from the firewall go to the Elasticsearch SIEM. You have to set that up as well. The firewall rules are to facilitate inter and intra guest communication so that the Kali instance can attack the damn vulnerable web application on the specific ports that we want. Then the damn vulnerable web application can contact the internet on ports 4T and 443. When you bring up the Elastic guest, it will print out the password to use to the terminal in this block, security auto configuration information, and at the end of the deployment. So note down that password. You can note it down in the repository in a file called password.txt that is in the gitignore file, so you won't accidentally commit it to change control. This is not ideal. Don't do this in production, but for the sake of ease of use, you can save it into that file and it's not going to be the end of the world. Again, never do that in production. Use a password manager. So it'll also print out how you can reset that password if you've forgotten it or lost it, which will be just about here. Once you're in the Elastic guest, so you could go Vagrant SSH Elastic in the specific directory that you've downloaded everything to, you'd run that command, which is the Elasticsearch reset password, and then specify which user you want reset, which is the Elastic super user. If someone gets access to this password, it's game over. So in production, at least, it's game over. They can do anything they want. They can impersonate whoever they want. They can shut down the entire cluster. They can manipulate some of the records, although some of them are very static, so that you can't actually manipulate them once they're in. But there are some things you could do, so just delete the whole index, and then there goes all your logs. You don't want that. Then the damn vulnerable web app installs. Something else as well to note, in the Elastic installation output, you'll see a lot of stuff in red. That's just a misinterpretation of the color codes. It's not actually erroring. It's just being printed in red because it would normally be printed in another color if you're running this with OMyZSH or Bash. So you don't have to worry about that. It's the, as I'll explain later, one of the sub modules that we're using to do certificate. Basically, we're deploying our own root certificate authority and then issuing the client certificates from there, so that we can use them to authenticate to the we can use them to not authenticate. We can use that for the TLS encryption from our browser to the Kibana instance. The small step CA prints stuff in red for that. Don't worry about it. Then the damn vulnerable web application. Again, a similar thing happens here. When the Elastic agent gets deployed, it'll print stuff in red. If it doesn't say like error or terrible or something like that, as long as it doesn't say that, it should be fine. And it should just be printing informational stuff for you. So it'll say, okay, the Elastic agent has been successfully enrolled in the Fleet server and that sort of stuff. So you don't need to worry about that. Then that runs, it's again very verbose. At the end, it'll give you information as to the username and password for the damn vulnerable web app. We don't need to worry about that at the moment, but you can note that down as admin and password. Again here, this is what you do if things have gone wrong. Then a key step is set the time zones for all of the guests to whatever time zone you are in. If you're not in UTC, in the Elasticsearch backend, everything is UTC. So if you're not, then you're logging, you could be either logging in the future or logging in the past. So you have to set each guest. So the firewall, you don't technically have to do it for the Kali instance because we're not logging anything from there. And then we shouldn't really trust like packet timestamps from there. It would much be from the firewall and from the damn vulnerable web application Ubuntu instance. So you'd use that command to set. So if you're in Europe, Frankfurt or whatever, you'd set the continent and then the city, and then that'll be a specific time zone to your location. Then as well, it's in the OpenSense firewall, system settings, general, and then in there you can set what time zone. The architecture of this lab, again, it's basically an entire enterprise network minus Active Directory, because we don't need to worry about that at the moment. We have the firewall, which is OpenSense, which facilitates the necessary communication between the guests and to leave. There is, like, I'm doing some metric trickery so that each guest, so the Elastic guest, the Ubuntu guest, the damn vulnerable web app, and then the Kali guest all get two interfaces. One interface is to be managed by Vagrant, and then the other interface is for the inter-guest communication, so that it can all route via the firewall. So here there's quite a lot of different aspects to this. So it's Elasticsearch, which is the storage construct. It's Kibana, which is how you interface with that storage construct. So it's the GUI, a sort of web GUI. Then there's Fleet, which is how the agents, so there'll be an agent installed on the damn vulnerable web app that then communicates back to Elasticsearch so that all of the data that we're interested in and that we want to monitor is logged correctly. Then there's Small Step, which is how we're doing the certificates authority. So it mints a new certificate authority every time you bring up the lab, but it gets seeded with a password so that if you go through the steps to incorporate that custom root CA to your browser and trust it to identify sites, you don't ever have to do that again. You could destroy the entire lab, it'll be brought up again, and you don't have to worry about that being the case every time, because I'm personally perturbed by the site is insecure. I know it's insecure, I built it. And then there's Caddy, which is how you will, it's the reverse proxy for how you will access the Kibana instance. So it serves the Kibana web interface, which is normally on port 5601. It'll serve that for you on port 5443 and then do the SSL termination. You're going to want to add these domains if you want to access them to your host file. That is it's a bit of a mouthful. So we can do a whichever flavor of text editor you want to use. I'm going to do sudo vim ec hosts. Do we get it right? No. Then here it's going to give me information about the hosts file. You're going to want to add a local address. So 127 dot whatever, it doesn't actually matter because it's the whole class 8, it's the whole /8 class A network. No need to worry. So you could do .0.0.1, you could do 1.1 if you're lazy. Then you add the domain name. So we have the OpenSense domain name here already added. We're going to change that to be the elastic as well. So, and then we want to replace that with cool. So now we've added the elastic domain name to the hosts file, so that that'll also route. Instead of doing proper DNS resolution, it'll use the local resolver and then look at the local address 127 whatever. We use .home.arpa because if you use .local, that interferes with some other RFCs. If you use just .whatever, then you're going to leak those domain names to an external DNS resolver. .home.arpa is the only recognized, backed by the RFCs, subdomain you should be using for local addressing. So just .home. It's a bit longer than .local, but it's recognized, so that's why we use it. Then we're going to write that file. So now we can access the firewall if you wanted to, if you want to do some configuration changes, or if something's not working as it should, or to set the time zones correctly from your host system. Access there you go. Tartarus-opensense.home.arpa :8443 because it's using a custom port. Don't worry about this. It is, unfortunately, due to the way that we're creating the certificates, it's not being done on the FreeBSD node. It's actually being done on the Elastic node, and then we're not seeding that certificate back to OpenSense because there's the red version and the blue version. If you deploy the red version, you won't get that initial configuration, so you'd never actually be able to send the certificate back up to OpenSense. So unfortunately, in this instance, we have to accept the risk. Then it's root and OpenSense. We're gonna say not now, thank you. And then you could follow the wizard. It's great advice, just follow the wizard. But in this instance, we're not going to. You'll do like we're gonna go actually back here, back to the lobby. Then you could do system settings and then set the time zone and stuff. So now we've accessed that. Now let's access the Elastic instance. So that would be similarly, PS is the protocol, elastic .home.arpa, and then at 5443. Again, you'd add the root certificate, which is located, if I do certs, so this is where you'd add this specific root CA to your browser's trust store so that you could then not get this anymore. So that's in the search directory of the Tartarus Lab. But for now, we'll accept the risk and we'll continue. Then we'll hit it with the elastic and then the password. So the password, as I said, is printed to the terminal. So we'll go, it's very verbose. This is just the damn web app still. So it'll be down here. Cool. There's my password. I'm going to do Control-Shift-C to copy it out of the terminal and then paste. For that, I'll save it. Doesn't really matter for this instance. Cool. And there you go. You've successfully installed the Tartarus Lab on your host system so that you can access and hack the damn vulnerable web app with a Kali instance that then all the logs will go to the Elastic SIEM. You can confirm that by clicking the burger icon. That's what it's called. So, and then going down to Fleet. And then here you should see all of the guests. I didn't check this before. Okay, cool. Everything's healthy. Everything's good. Awesome. So you'd have the Linux Apache agent policy that applies all of the specific settings for Apache logging. And then there's the Fleet policy. So on the Elastic search, on the Elastic guest, that's where the Fleet server is. And then there's the agent on the damn vulnerable web app guest that then communicates via ports 9200 and 8220 for logging from that guest to the SIEM. But you've installed everything, and then you should be able to carry on with the rest of the blue team parts of the guides. Great. Now, if, however, you want to understand how this stuff gets deployed, I'm going to now go briefly over how exactly we deploy this stuff with Vagrant. So in the GitHub repository, a lot of the stuff is, for 2 years, trial and error, trying to get this stuff to be as automated as possible. So there's the apps directory that stores all of the applications that you don't have to download again every time, because I don't want to hit the Elasticsearch artifact repository with downloading it again and again and again. So everything gets saved into that directory. It's in gitignore through a sort of workaround where it itself has a gitignore file, so that all of the downloaded applications don't then also get added to your change control, because you wouldn't want that. Okay, then we go to certs, is where the certificates are downloaded to. Config, this has all of the specific configuration items. So you can see there's quite a few. These are for the specific logging policies, would be your fleet integration, the .jsons. So we interactively do it via the Elastic or Kibana API. And then there's some headers for curl to use. Then there's the Kibana.yaml and then the Elasticsearch.yaml. Those are the configuration files that seed how Elasticsearch and Kibana respectively deploy. So then we have images, keys. That's where all of the keys are downloaded or are saved to. So there is a super user API key that gets saved, and then there are other keys throughout the deployment process that get saved into that directory. It's the only, unfortunately I couldn't find a way to do this otherwise, it's the only directory that will be interacted with on your host system that we have to delete. I've tried to script it as safe as possible, that only that when you run vagrant destroy Elastic, it'll delete all of the files in that directory. We need to do that so that the next time the system gets brought up, it's an entirely fresh start. There was no way to do that in a sensible manner, unfortunately, other than deleting the files in that directory when you run vagrant destroy Elastic. It's a bit unfortunate, but here we are. Then there's some template files for nuclei. There's all of the Sigma and converted rules to Elastic in the rules directory. Then there's some Sigma configuration stuff. So I've had to write some template files to be able to use effectively the Sigma rules with Apache. So for example, this is a pipeline file that'll change and rename the Sigma keywords into what it's related into the Elastic Common Schema or ECS, so that, for instance, here client IP becomes source IP in the SIEM when we convert the rules. So I've had to write a few of those, but you don't have to worry about them at the moment. Then there's the example M file, which is how we can, it was kind of for interacting with it via an API and like via some scripts. I've actually moved all of that to another project, the Omega CLI project, so that we can interact with the SIEM via a Python script, so that we can run any of the tests that we want to, and then make sure that they are replicated in the SIEM, so we don't need to worry about that. Then the gitignore, so that has some important files in, namely the password file, if you wanted to save that, and then the .m file, because we don't want that back to change control. I do understand that in production, we don't want to actually have .m files. We want to have them created at a runtime from a separate server or via like HashiCorp Vault or something like that. I get it. But this is, it's just a lab. It's just a lab. Then there's these files, which all pertain to how the guests deploy. The most important of which, for our purposes today, is the ES Bootstrap file. So this deploys. So it does a lot of things. We make sure that it can reach the internet to download the packages. If not, it fails. We then download, first we make sure the firewall is reachable, because if it's not, then the way that we've deployed and architected everything, it'll just fail. Then we make sure the internet's reachable. Then we download the packages. Then we download all of the, we set some of the variables in a variable file so that we only have to change it once. We don't have to change it everywhere. I found this so much easier. So we just set all the variables that we want. So the Elastic version that we're going to be using, some of the IP addresses. It's a bit of a holdover from doing it per file basis. So it's not like Elastic IP, but there is the K for Kibana ports and all that stuff gets defined in here. And then at runtime, we populate those in the script over here. Then we echo those into, some of them into the etc hosts file of this guest. And then we download the specific packages that we need. Don't need to worry about that now. There's a little function that does that. So then it downloads and verifies the checksums. Then we, through RPM, this used to have some trickery because Elastic didn't have an up-to-date signing key. That's now fixed. So everything can work like this, which is great. Then we install Caddy for the reverse proxy. And then we also install a small step CA. So then here, this is if the CA password, so the certificate authority password doesn't exist, we then create it, and then that gets seeded and saved. And then that then gets used later on to seed the certificates every time. So you don't have to, once you import it into your browser the first time, change it. So this initializes the certificate authority. Then we do some changes. So we'll make this like a 10-year certificate, which is great, through JQ, which is how you can very nicely interact with JSON objects via the command line. Then we do some more variable declaration. So then to do all of the certificate instances, we make some directories, we copy some stuff. Don't need to worry about that. And then this is again more of that. Then here we do some. So you'll notice there are the XPack variables. These get created from udev random at deploy time. So you'll notice in the config, there you go, cool. So that's where these variables come from, is they get created at runtime with random variables that then get seeded, with random values that can then get seeded. Then we start and enable Kibana, and then this is how we do all of the settings through curl. So we send curl requests for each of the processes that we want changed, so that it's all API based. It's zero touch provisioning. Why not go through something like Ansible, Chef, or any of the other? Because this is it's just easier. It's once you get to the level, then you can read this stuff and understand and go, okay, oh, that's what you're doing, Dylan. Oh, that's what you're doing, Dylan. Oh, that's what you're doing. That makes sense. Or that doesn't make sense and it's terrible. Throw it away. Start again. Happy days. Here we then, again, through the event substitutions, add the header field, because there's some headers that are special, that you have, some endpoints have to have the special headers. If it doesn't have the special headers, Kibana fails. So we don't need to worry about that too much at the moment, but this is how it's all set then. So we also do some policy replacements, and then we're going to say this enables all of the SIEM rules in like one call, all of the Windows and Linux SIEM rules, to be specific. If you wanted to enable any other rules, then you could add that to the list there, or you can go through and enable them manually through the GUI. We'll have a look at the Vagrant file briefly. So again, this is the firewall. If you watch the red team perspective, that's how the firewall gets deployed. Then this is how the Elastic guest gets deployed. We do here, this is where the host's environment variable comes in handy, is that we can say, okay, if hosts is none or hosts is Elastic, then set these and deploy these scripts. If the host is Windows, deploy these scripts. If it's Linux, these. If it's LinWin, these. And then if it's the damn vulnerable application, those. Then there's also some trickery that I've had to do. If it's running on Windows, there's some things that don't work, that will work via Windows to delete the keys, and then there's some things that work via Linux to delete the keys, because that's how they get destroyed. If you run Vagrant Destroy Elastic. Then the Linux guest, that's how it's provisioned. Then the Windows guest, that's how it'll be provisioned. In here, you can also change. So for this instance, the Kali instance, you could say, okay, I don't want 6 gigs of RAM. I only want 4 gigs of RAM. Edit this here. And then the next time it deploys, it'll only have 4 gigs of RAM. Or it's got too many processors, reduce it. Or it's got not enough processors because I'm doing some hashcat stuff, add more processors to it. That's where you'd alter it. And then, so yeah, that's now finally, that's it for the scripts. And then this is just explaining how to access these things, some of the firewall rules, and then how to access the Elastic SIEM and the Danvon web application and Kali. And that's it. Thank you so much for joining, and I hope you enjoyed. I'll see you in the next one.